Hi, my name is Mastrapa.
My name is Javier Seoane.
And I'm Aaron Solomon.
And we are Team 11, and our topic was robots in the construction industry. In particular, we chose the excavator.
Okay, so excavators. They're commonly known as diggers, and they consist of a boom, an arm, and a bucket, which usually works with hydraulics. The robots in the construction industry, the typical one is the 3R, 3 degree of freedom robot, which uses its bucket to dig into the soil and uses the boom and arm simultaneously to lift the material collected and to relocate it to its specified location. The most commonly used robot in the industry is the 3R, 3 degree of freedom robot. Next slide. Okay, so some typical trends in the field. The entire construction industry is almost solely based on robotics, since the basic task in construction is collecting material and relocating it to a different location. Other than trucks, 90% of the machines involved use robots with prismatic and revolute joints with an end effector.
Caterpillar Inc. pretty much dominates the construction industry. Now, they're also known as CAT for short. They design, manufacture, market, and sell machinery and engines used in the field of construction. The reason why we picked Caterpillar Inc. is because they are the world's largest manufacturing of construction and mining equipment. Caterpillar's line of machines include hydraulic excavators, backhoes, loaders, motor grades, and bulldozers. Next slide. Now, the early practice of excavating began with the use of steam shovels. The steam shovel was invented by William Otis in 1839. They were first originally known as partial swing machines because the dipper arm could not rotate through a full 360-degree motion. Now, the shovel and driving engines are mounted at one end of the chassis here, which accounts for the limited mobility. They were built on railway chassis. You can see the railway tires here, and they were and the boiler and movement engines were mounted at the end of the chassis on this side. Now, the first full swing revolving shovel was not invented until 45 years later in England.
As for the future of excavation, Volvo is currently designing the new, it's called the Sphinx, it's the new, it's a concept design, but it takes into account many changes that other companies want to see in the industry. As you can tell here, there's a glass cab surrounding the user, as well as a virtual safety belt, which takes into account anything surrounding the area, because even though he can see all around, he doesn't have full visibility. And it has independent tracks, which none of the excavators have nowadays, which accounts for different terrain and different levels of terrain. That way the excavator doesn't tilt over, which is accountable for many deaths nowadays. It has a detachable cab, as you can tell, where the user can remotely operate the excavator from a far distance in case there's a biohazard area or rough terrain like mud, in which case it can increase the contact area of the wheels and it can adjust to many different types of terrain. It also has a bucket cam where the user can control and view what it's gathering from a far, safe distance. Now I'm going to pass it off to Javi, who's going to talk about the procedure that we went through in this project.
In this project, we went through inverse position analysis for a 3-revolute, 3 degree of freedom robot. Now, we specified a range of end effector positions which we wanted the shovel to travel through as it excavated. Using inverse position analysis for 3-revolute, 3 degree of freedom robots, we determined the joint displacements. And we also had to ensure that there were no singularity positions in our calculations, which would be accounted for by two links having a degree between them of 180 or 0 degrees. Now, here is a chart illustrating end effector position as well as joint displacement. The imaginary line connecting the origin and the red dot illustrates the path followed by the first link, which is the boom. The imaginary line connecting the red dots and the green dots illustrates the path of the second link, known as the arm, and the imaginary line connecting the green dots and the blue dots illustrates the path of the third link, which is the shovel. And at the bottom, you can see the scoop motion occur.
Okay, so as previously stated, our model that we created is a 3R, 3 degree of freedom robot. Its general purpose is to excavate the ground, relocate soil, and move it to other locations. The two tasks that we came up for our project was lowering the boom and the arm simultaneously, followed by scooping with the bucket, as well as our second task being raising the boom and the arm simultaneously and emptying the material of the bucket. The constant robot parameters that we determined was the boom arm, the arm length, and the bucket length. And the projected workspace area was roughly 169,000 meters squared. In this video, we illustrate the boom and the arm simultaneously moving on its way to collect the material below.
And in this video, you can see the actual bucket scooping up the material, which is all part of task 1, as Aaron said previously. And following this task 1 would be task 2, in which the arm raises itself and lets go of all the material that it has inside of the bucket. So in conclusion, we developed a working and effective excavator using inverse position analysis for 3R and 3 degrees of freedom robots. With this, we acquired accurate joint displacements, and we finalized the desired movement of our robot. And pros of our project: with this method analysis, we can visualize the task before we are actually implemented into production, which will save companies a lot of time and a lot of money. And the con, in particular, as to our project, we did not take forces into account, which involve the weight of the material as well as the weight of the arms. And that can have a huge effect in the end result. And because of this, we can't operate in real-life situations. So if we were to attack the problem again one more time, we would take into account these forces, which would allow us to calculate more accurate joint displacements. Now, that wraps up our presentation. Thank you very much for your time.